In today's class, Academic Daddy will be teaching you how to solve fractional equations. Fractional equations. So when we have fractional equations like this, notice that there is no x down here, there is no x down here. So this can never be a partial fraction because the power of the numerator is greater than the denominator. So we say it's a fractional equation. So when you have this kind of equation, some textbooks or the way some people go about it, they will say the denominator here, the LCM is 20. They will tell you multiply both sides by the denominator. But I like to do dividing both sides by the denominator so that I have this to be 5 times 20 has nothing in common. 5 and 4 has nothing in common. So 5 times 4 is 20. That's the LCM. So 5 into 20, I have 4. I have 4. So that 4 will times everything up here. Minus 20. If 20 come up here and 4 divides it, I'll have that this is 5 into everything here equals to 1. So when you times this is 12x plus 24 minus 10x, that is minus times this 10x minus, you know that multiplication can multiply or is distributive, you can enter anywhere. So minus 10 all over 20 equals to 1. So collecting like terms, I have that this is 12x minus 10x plus 24 minus 10 all over 20 equals to 1. So this is the sentence as 12 minus 10 is 2x, 24 minus 10 is 14 all over 20 equals to 1. At this junction, we remember that anything standing on its own is over 1. So we can say cross multiply. So if we cross multiply, this is 2x plus 14. 20 moving to this with times 1. 20 times 1 is 20. So this is the sentence as 2x equals to 20 minus this 14. Is the sentence saying subtract 14 from both sides so that this can be standing on its own because we are trying to make x coefficient subject of the formula. So this crossing over becomes minus 14, so that this becomes 6 to x. So divide both sides by coefficient of x, which is 2, so that this becomes so this is our answer. This is our answer. This is our answer. X is equals to 3. So the next question we have is a question like this. A question of this nature. Next question before us is something like this: 4x all over x minus 5 raised to power 2. This is the question before us. So notice something. Do you know that this thing is the same as 4x all over x squared minus 5 squared? So notice the power of x here is greater than the x in the numerator. So this can be resolved. This can only be resolved by what we call partial fraction. And this type of fraction, partial fraction, is what we call repeated linear fraction. So it's a repeated linear fraction. Repeated linear fraction. So to solve this now, let's go back to this approach. I use this to show you that it's a partial fraction because the power of x in the numerator is 2, while the one up here is 1. So to solve this, I have that this is the sentence as 4x all over x minus 5 square equals to, now since this is repeated, this thing is the sentence as x minus 5 square. If you have this and you get it to be x minus 5 raised to power 3, it will be x minus 5 square, x minus 5 cube. If it's x minus 5 raised to power 4, it will be x minus 5 square, x minus 5 cube, x minus 5 raised to power 4. Very important to note. So now that you know this, so assuming I have this in raised to power anything, it will be continuous till it gets to the last one. Now, if that be the case, I will now say this is x, this is 4x, and if this is 4x, you know that what I have here will be the same as saying a, and what I have on this part will be